The Bureau of Meteorology hosts a range of critical data sets on its FTP site. These are used across a range of industries, and we have everything from frost warnings to fire to flood, cyclone. There's an extensive catalogue of information that's available on this site. There's also a weather station network, and these state-based observations that update in near real time. What we want to do is we want to connect to these frequently changing data sets, and then using the Microsoft Power Automate platform with the ArcGIS Connector, hook into those, do a little bit of processing on them, and then ingest them into the ArcGIS, in this case, a hosted feature service in ArcGIS Online. That then gives us the latest readings from that layer. So we can see, as per usual, up north is hot and down south is cold. We can see the wind speed and direction. We can see Tassie's got some high winds at the moment from these weather stations. Rainfall in the last 24 hours. And then this max daily gust. And what we're also going to use Microsoft Power Automate for is connect to the Digital Atlas of Australia and pull in the overhead utilities lines and work out which ones of these utility lines are within a distance close to these weather stations reporting high wind gusts, and showing them here highlighted in pink. We've got a blog post that will go into some more detail, but those that are interested, what we do here is every 20 minutes we connect to the Bureau of Met or initialize this Microsoft Flow. These are the products that we're interested in getting from the FTP site. We initialize a variable to store the XML for each of these in there. We then loop through this, and we use the FTP connector to connect to the FTP site, get that specific FTP product, and append it into this array. So we essentially build up this big array of XML for each of the states and their observations. Then for each of those XMLs and the rows, if you want to call them that, we loop through and pluck out the stations. And then for each of those stations, we then essentially get the readings for each station. Go, okay, we need the wind gust speed, we need the rainfall, and we compose that into a packet that we could then write into the GIS layer. So that's how we actually get the data from the FTP and into the hosted feature service. And then again, for these pink lines here, and we're actually doing this kind of processing, I've separated that into a different flow. So in this one, we're listening for when that weather observation layer is updated, using the trigger here for when a record is updated in the stations layer. We then just loop through and delete any of the previous records that were in that impacted lines layer and purge those out. We then connect to the stations layer and work out, well, look, where is it where the wind gust speeds are over 35? And you would adjust that to whatever value you think's critical for your threshold. Get those, and then we would loop through each of those geometries and work out, okay, well, for ones that are reporting a high wind gust speed, go off and query the Digital Atlas of Australia just for the overhead utility lines and look for a distance of 40 kilometers from those overhead lines to essentially work out how many, return the polylines that are within that distance. And then with those polylines that are returned, we would then write them back into this particular layer, which is that layer that we see here. It's these pink ones here. And every time these two flows run in tandem, you then keep not only the observations up to date, but it will keep changing which utility lines are within a distance of those high gust speeds.